You're listening to The Naked Pravda. This is Medusa's first and only English language podcast, so please don't be shy about recommending us to your friends and leave a review on Apple Podcasts or wherever you're tuning in. Welcome to The Naked Pravda. I'm your host, Kevin Rothrock, the managing editor of Medusa's English language edition. And today's show is a little bit different from usual because I did not conduct the interview you're about to hear. That honor goes to Alexander Urshov, Medusa's science editor, who spoke to Marc-Michael Blum, a biochemist who studies decontamination, countermeasures, and the mitigation of chemical warfare agents. In other words, Dr. Blum is no lightweight. In 2018, following the Novichok poisoning of Sergei and Yulia Skripal in England, he led the team sent to Salisbury and Amesbury by the Organization for the Prohibition of Chemical Weapons. Just to bring you up to speed, as of September 11th, 2020, the German media reported earlier this week that Russian opposition figure Alexei Navalny was poisoned with a new type of Novichok nerve agent, something more dangerous than any previously known variation. Navalny was apparently supposed to die on the airplane during his flight home from Tomsk to Moscow, but he survived, supposedly, thanks to the pilot's decision to make an emergency landing in Omsk and the doctors who quickly treated him with atropine, an antidote used against some types of nerve agent and pesticide poisonings. Doctors in Germany subsequently found toxic residue on the neck of the water bottle Navalny drank from while on the plane, as well as on his hands. The German authorities reportedly believe that one of the Russian agents tailing Navalny could have planted the poison on the surface of the cup he drank tea from at the airport in Tomsk, or maybe slipped it into the brewed tea itself. Medusa's interview with Dr. Blum was recorded just before German officials announced that Navalny was poisoned with the Novichok-class nerve agent, which might lead you to ask why we should care about this if the interview took place before that confirmation. Well, even before that announcement, which came on September 2nd, it was pretty clear that Navalny had been exposed to a nerve agent. But I think you, and I know I, benefited from hearing more about the analytical chemistry that's required to identify these poisons, and know more about what the outlook is for Navalny's total recovery. These are all questions that Dr. Blum answered and explained in his conversation with Alexander Urshov. In fact, if you write virtually anything online today about the German researchers' work to identify the poison used against Navalny, you're very likely to hear from skeptics who distrust their conclusions. Also, when I tweeted about Dr. Blum's responses, I described him as basically the real-life Nicolas Cage character from The Rock, aka Stanley Goodspeed, which Dr. Blum wrote about on his blog. He also pointed out that VX nerve agent is not actually green, so The Rock lied to us. But luckily, we have Dr. Blum here to set the record straight. A full transcript of his remarks is already available at Medusa's website, but I wanted to make this conversation available to our podcast listeners as well.
You take a blood sample. In the blood, you have cholinesterases. And there are tests where you can just check if they work. I mean, a cholinesterase is an enzyme. It actually helps to speed up a certain chemical reaction.
That's Dr. Marc-Michael Blum explaining cholinesterase, the enzymes that serve as neurotransmitters inside your body. As you may know, Navalny was exposed to some kind of cholinesterase inhibitor that suppresses the action of the enzyme. That's why he's been sick. Medusa asked Dr. Blum how doctors are able to know that Navalny was exposed to something like this without being able to identify exactly what it was.
There is a test where you are not using acetylcholine, but acetylthiocholine, very similar. And the cholinesterases work on that as well. And what you get as a product, then you can react with something else and it creates yellow color. So that's a classical test for activity. And with that, you measure the activity of the cholinesterases in the blood plasma. And what they probably saw is a significantly reduced activity level. And you can, if you say your cholinesterases, you have a level like this, you can, even with this, you have very minor symptoms. And only when you get almost to zero, it gets really severe. So with the symptoms Navalny showed, with the fact that they had to put him in induced coma, and the fact that they probably tested the cholinesterases in his blood and probably saw very, very low levels. That triggered the press release saying We see there's a cholinesterase inhibitor, but we don't know which one. If your cholinesterases are in fact inhibited, most of it is inhibited, it means that something is sitting inside or on that enzyme. It's still there, because if it's not there, then it would be active. So yes, when you measure blood that shows big inhibition of the cholinesterases, the poison is there. Because if the poison would be gone already, the activity would be back. So that is a good sign that the poison can be found. There's a cholinesterase in blood, which you mainly look at. It's called butyryl cholinesterase, BCHE. That's soluble and easy to work with. And if you have an inhibitor, it will inhibit that cholinesterase as well. And then you look at it and you try to find two possibilities. Some of the inhibitors are actually, it's called reversible. So they only stick like glue, but they can go off again. And some others, like the nerve agents, the warfare agents, they actually bind to the enzyme and you cannot break that anymore. It's really just like super glue, so it sticks. And what you then do is that you look for these fragments from the poison that sit on the enzyme. So you take the enzyme, you cut it in small little pieces, and there's a very characteristic piece, and on this piece you expect to find something sitting on it. Then you use mass spectrometry, and you know the mass of that fragment if it's normal. And then you expect that fragment also to be there with something to be heavier because something is on it. And from these exact masses you have, you can deduce what's on it. And once you think you have found something, ideally, if you have that poison available, you take some blood plasma from somebody else, and in the test tube you add it, and you also measure this. And if it looks identical, you have a confirmation that you found the poison.
Another common criticism from skeptics who question claims that Navalny was exposed to a nerve agent is that the doctors in Omsk who treated Navalny initially say they tested him for poisoning with cholinesterase inhibitors, but they couldn't get any confirmation. Medusa asked Dr. Blum if there's any rational scientific explanation for this.
I don't think so. I mean, because the first step you do is this test for the cholinesterase activity. It's you can do it very sophisticated. In principle, it's quite a simple test. You take the plasma, you have your acetylthiocholine, and you do that in a little glass cuvette, and it creates color. And all you need is a photometer, which is a very usual lab equipment. And you have that everywhere. You don't need super sophisticated technology. And with that, you can do that test. And Charité found inhibited cholinesterase. Then it should have been found in Russia as well. Because, of course, I mean, what you hear now are these speculations already from some. I mean, if you read Twitter, it's like, oh, maybe he was poisoned on the way on top of this metabolic condition he had. Yeah, well, of course, that's a possibility, but how likely is that? Yeah, he was severely ill when he was found and taken off that airplane. And the question I ask myself is that the Russian hospital said he got atropine, but they also say he had very low blood sugar. When you have very low blood sugar, normally your heartbeat goes very fast and you sweat. And atropine is given if your heartbeat is very low. You don't give it if it's really high. It's very unusual. So if they gave him atropine, there must have been a reason to give it. And I think they have not yet explained why they gave him atropine. I mean, you're not just giving atropine to somebody who is severely ill just as a precaution. Must be a clear indication why you're giving a certain antidote or why you think you need that emergency medicine to stabilize the patient. And I haven't read anything so far saying why did he receive atropine. There's no good explanation at this moment.
Dr. Blum also dispelled another popular internet theory, this one promoted by some of Navalny's own allies, that Navalny was kept in Russia for as long as possible to give the poison in his body time to disintegrate, making detection impossible. Medusa asked Dr. Blum how plausible this would be. How quickly do these poisons break down in your body anyway?
Some of these compounds hydrolyze quite fast in the body. Like if you look for a nerve agent, sarin, for example, is very fast to hydrolyze. But it attaches to the enzyme permanently. You can always measure that. The body is remaking cholinesterase. If you have knocked out cholinesterase, it takes about 2 months to get back to normal. And effectively, you can take samples 3-4 weeks after exposure. You still find it. What is gone quite fast are the metabolites in the urine. Urine normally you have 2-3 days, and then it's gone. But what sits on the protein, on the enzyme, that stays for a very long time. If it would have been hydrolyzed and completely gone, Charité would not have measured inhibited cholinesterase. Keeping him there just for the poison to disappear in case of this poison group doesn't really work. There are other poisons where waiting for a couple of hours is quite effective. In the end, the question is also, everybody says he was poisoned by drinking a cup of tea, but that is not proven. He could have had contact with a poison somewhere else earlier on in his hotel, on the way to the airport, in the airport, wherever. It's just that people said, oh, he had a cup of tea at the airport and it was the only thing he had this morning, that people focus on the tea. But in case of other poisonings, we had recently, like Sergei Skripal, for example. Yes, he went to town with his daughter. They had a pint of beer in a pub, yet the poisoning occurred somewhere else. So that is still, for me, not totally clear that it was the tea. And it depends what they will find in the end. If the tea theory is plausible, or if it's more likely that it happened somewhere else. But if it happened somewhere else, so he got in contact with it through the skin, then of course it's also quite dangerous for everybody around him, because he's contaminated and he will potentially give that contamination to other objects and people he touches.
Dr. Blum also anticipated German researchers' problems with identifying the exact poison used against Navalny, though scientists did subsequently conclude that he was exposed to a Novichok-class nerve agent, reportedly the most dangerous variation yet documented. When you hear what's involved in detecting these compounds, you'll realize what a wonder it is that they're able to learn anything at all.
Is it possible that they will not be able to identify the poison? In principle, yes, because there's such a wide range of possibilities here. And the concentrations you look at are very small, which means you have to look for every single possibility. It's like, okay, now we look for this, now we look for this, now we look for this. And you go through the usual suspects, the usual nerve agents, the usual most used pesticides, etc. But it can be a quite long list. What you would also do, of course, you would still look, is there still something in his urine? Is there something in the blood which is the hydrolysis product, small molecule, a metabolite? Maybe they take white samples from the skin to see, is there something we can get from the skin because it's still there, which might help them to support the analysis that is done with the cholinesterase in the blood. So you're looking at a lot of different angles. I'm still quite confident that they will find what it was, or at least the general class, because that's one issue. Not the whole poison molecule attaches to the cholinesterase, but some part is lost. And so in case of sarin, for example, the fluorine is lost. So you can say if the poison was something looking like sarin, but instead of fluorine, there was cyanide or something, or bromine. Yes, that's a possibility. You don't know that because that part of the molecule is lost, but the rest looks like sarin, and it was powerful enough to attach to the cholinesterase, so you know it's definitely a nerve agent. So I'm actually quite confident that it will be found, especially because his condition actually indicated quite severe poisoning, which means he probably ingested or absorbed a quite high dose.
Some listeners might still be tempted to dismiss the chances that Navalny was attacked with a weapons-grade nerve agent inside his own country. The implications, after all, are severe and strongly suggest that the state authorities were involved. Maybe Navalny merely came into contact with an ordinary pesticide, right? Dr. Blum says that simply doesn't fit the facts. He also offered some interesting history about the development of poisons.
Some of the pesticides are organophosphorus compounds, just like the nerve agents, a bit different in structure. But the big difference between is the toxicity. You need to take a lot more or ingest a lot more of the pesticide to have these severe toxic effects. There might be a few milligrams of, say, let's take something very poisonous, VX. VX on your skin, little drop might kill you. If you take one of the usual pesticides, a drop on your skin will not kill you. So the difference in toxicity might easily be 1,000-fold more toxic or less toxic. So there are really big differences. And if you look back in history, how the nerve agents were found, it was normally that work towards new pesticides or insecticides. And some of these turned out to be very effective, but unfortunately too toxic for use because they were really toxic to humans. Those developments would then go into the military use and say, this is probably a very good warfare agent. And those that are effective against insects and not that toxic to humans, they would go for civilian use, become pesticides. With a life-threatening condition, there must be so much of it that you should really find it. I mean, there are also some other cholinesterase inhibitors. For example, there are even some medicine therapeutics you use for Alzheimer, for example, and carbamates, non-phosphorus class of inhibitors. So all these can also have these effects. This is why it's hard to find, because you have to look at so many different classes of chemicals. But at the moment, given what we know, it's really, really difficult to speculate on that. Yes, if it would be a normal pesticide, you would think there must have been a lot in that tea, if the tea hypothesis is right. And by just touching some contaminated surface with a pesticide, that won't be enough to get enough inside your body to kill you. But then there are ways to enhance penetration of chemicals through your skin. That is also a possibility. So there are still so many unknowns. I think the next thing to do is to wait now for the identification. And once we have an identification on what the chemical is, to then go forward and okay, is it still likely that the tea was the source of poisoning? Is it likely, between the tea, I think, and the moment he really dropped down on the airplane, it took a bit more than an hour. Is that realistic? Quite a lot of even of the pesticides act faster. You would expect that people after 10, 15 minutes, especially with an empty stomach, would start to show symptoms.
Alexei Navalny fell ill on August 20th, 2020, which was nearly a month ago at the time of this recording. That's a long time, and he's only now very gradually coming out of his coma. Medusa asked Dr. Blum why this is taking so much time. What are the doctors waiting for?
In principle, they want to see that the cholinesterase levels go up again. Because if you're really knocked out on your cholinesterases, the symptoms you show, even with atropine, there will be the typical symptoms. You cannot control your muscles. You need ventilation. You cannot breathe yourself. And being intubated, for example, for the whole time is quite harsh on the patient if he is conscious. Normally, you sedate the people, put them in a not very deep, but shallow coma. Also, they don't have pain. They can tolerate the ventilation much better. And you also don't abruptly take them out of the coma. You just start. They constantly need to be given certain medicine to be in that coma. So you slowly take it off and you see how the patient reacts to it. And if you see that he's in a lot of pain or he's getting spasms or so, you will keep him in the coma. But in parallel, you will measure his cholinesterase. And if he's back again with 10% activity or so, 15, you can start taking him out again. But in the end, that decision lies with the treating physicians. Yeah, they are the guys who really know. But it's really basically that you are not that much in pain. Being ventilated is not a very pleasant experience. It makes sense also basically to keep the body down. But that coma might easily last for a couple more weeks. They said his condition is improving. It's severe but stable. That means it's not life-threatening anymore. But severe still probably means we are keeping him in that coma for the time being. Atropine is not helping you with the blocked enzyme. It's helping you because it's basically working against the symptoms. There's a second class of therapeutics. You give oximes, pralidoxime, obidoxime. With some organophosphorus compounds, etc., they can reactivate the cholinesterase. They are reactivators. If that works, they can help getting you out of that condition, but it only works with certain compounds and not with others. And if it doesn't work, then you simply have to wait, until all the poison is gone from your body, so it cannot inhibit the newly made cholinesterase, and then your body has to reproduce it. And that can take several weeks.
Given the evidence that Navalny was attacked with a Novichok-class nerve agent, what can we conclude about the assailant's intentions? Russia has seen its fair share of poisonings over the years, and many of them have curiously failed. Dr. Blum says it's unlikely, however, that attacks using such powerful poisons are intended merely to frighten. They're just too damn deadly.
Assuming it is a military nerve agent, then I would say it's definitely an attempt to kill, because you cannot fine-tune it. With these kind of compounds, as you have basically a curve where it says, okay, at a certain dose, you start seeing effects. And then at the next dose, the people die. And with the nerve agents, this window is extremely small. So between first symptoms and actually death, the window is very narrow. With the pesticides, it's wider. You see symptoms, but it still needs a lot more of the stuff to actually kill you. It's also true for some other inhibitors. So again, that's why I said it's important to see which poison was used, because if it is a military nerve agent, then you would say this was in all likelihood a real attempt to actually kill him. If it was something else, you could still speculate if it was maybe just a warning, but on the other hand, it doesn't really look like a warning, no? given the severe condition he was in.
But if these nerve agents are so fatal that they always indicate attempted murder, why do they fail so often? It was just a couple of years ago, after all, that the Russian authorities allegedly tried to assassinate the Skripals in England. Dr. Blum acknowledges that there are certainly easier ways to kill people, and he says the use of something like a Novichok poison suggests the desire to send a message by killing someone exotically, as he puts it.
Well, it's very cynical to say that, but if you really want to poison a single person and to kill him, there are better poisons. There are poisons which are much harder to detect, which are faster to act. And again, just because something is used as a chemical warfare agent, where you think about battlefield use, using in grenades and poisonous there is different from the perfect poison to assassinate somebody, because you need a different profile. Again, of course, this is very exotic. You could also say if you want to kill somebody, people just disappear, have a car accident, whatever, or just shot. By using poison, probably there is an additional message to get attention to the case. In case of Skripal, one has to say both him and his daughter were extremely lucky that when they collapsed, that the ambulance really arrived that fast and gave them treatment, and they were moved to the intensive care unit that fast. There are numbers out there saying if the ambulance would have arrived 10 minutes later, they probably would be dead. So, but of course, we also had very exotic poisonings which succeeded. Litvinenko with the polonium. Again, very exotic. Why go through all the hassle of using polonium, which is very hard to get? So probably if you simply want to kill somebody, there are probably easier ways. It's very hard to say. Maybe it's also, but that is pure speculation, that you say, I want to assassinate, but if he survives or she survives, well then, still the message is there. But it might also simply be a lack of experience on the side of the operator. So yes, these people are, whoever did it, probably the people who actually gave him the poison or put it somewhere are not the people who are the total experts in the poisonous properties. And they were probably told what to do. And then they used a bit too much, a bit too less on the wrong side. I think it's always very difficult if you use a contact poison, something which you have to touch, because then you never know what happens next. The person touches it with his hand. For some reason, he thinks, I go and wash my hands. Then most of the poison is off again. So that's very unpredictable. Of course, if you put something in a drink and the person will drink it completely, then that's a bit easier. But again, that's pure speculation. And again, I would say, let's wait till we know what it is. That might enlighten the situation a bit about what's behind it. That's also one thing to say. Chemical analysis alone will never be able to show who the perpetrator is. You need police work for that. And even if you find small amounts of poison in his body, the concentrations are so low that it doesn't have a fingerprint or signature, where you can say, oh, based on these impurities, we can probably think that it was made this and this way. That might be possible if you have a lot and you can analyze the pure substance, but in a person, that's not possible.
You've been listening to The Naked Pravda, an English language podcast from Medusa. On today's show, we heard from Dr. Marc-Michael Blum, a biochemist who studies decontamination, countermeasures, and the mitigation of chemical warfare agents. Medusa science editor Alexander Urshov interviewed Dr. Blum about poisons and the attack against Russian opposition figure Alexei Navalny. A full transcript of Dr. Blum's remarks is already available at Medusa's website. The Naked Pravda is a podcast from Medusa, our first English language show, and I hope you'll recommend us to your friends and leave a review on Apple Podcasts or wherever you're tuning in to help put this program in front of more folks. Thanks for listening and come back soon.